First skill for the Unit 6 through 7 review is a scatter plot. So what we do is we take some real life data, like in this graph, and we're going to plot these. Here, the years is like our x value, and the average annual per capita consumption is our y value. You can think of this as like a coordinate 1998, comma 23.9. And if I plot all of those points, this is about what my graph looks like. Now we're going up and down, but I'd say largely my trend line would look something like this. Not a perfect fit for every single dot, but generally we're going down. They want to know in 2007, so 4, 5, 6, over here is 2007. If I follow that up, maybe 21 gallons per person. Next up, let's talk correlation. If, on average, as the x goes up, the y also goes up, we call that a positive correlation. As the x increases, if the y decreases, we call that a negative correlation. And it's possible that there's no pattern at all, and we can just say no correlation. Here are some scenarios: the number of chickenpox vaccines given and the number of cases reported. If you are giving more vaccines, theoretically you will have fewer cases. That would be a negative expectation. If the number of vacation days goes up, then job satisfaction is going to go up as well. I expect anyway. People like taking vacations. If you want to know if this is a linear function, you can look at the pattern between the x's and the y's. The x's are going +1 every time. If you look at the y's, we start with +1, but then it's +2, +4, and +8. So that is not a consistent change. This is not linear. And I think this right here would be explanation enough, but your y change is not constant. It would have to be the same thing every time. This one on the left here is linear. If you rearrange this, you would get this, which is definitely y equals mx plus b and a line. Because of this exponent, this one is not a straight line. Do these ordered pairs satisfy a linear function? Let's look at the pattern. +1, +1, +1, +5, +5, +5. This is a linear pattern. It's adding the same every time to both x and y. Or another way to look at it is the slope is 5/1 all 3 times. So yes, same rate of change. For linear, that means a straight line. This one is a straight line. This one is not, it curves, and this one is an absolute value function. To find the x and the y intercepts, you're going to plug in zeros. For example, to find the x-intercept, you have 3x minus 2 times 0 is equal to -6. And it's like this part is just gone. If 3x is -6, then x, when you divide by 3, is -2. You can also think of that as a coordinate. This is the coordinate -2, 0. To find the y-intercept, we're going to plug in a 0 for x. So we have 3 times 0 minus 2y is equal to -6. And 3 times 0 pretty much goes away. When we divide by a -2, we get 3. And you can think of this as the coordinate 0, 3. Next up, to find the x-intercept, it's like we cover up the y. 2x is 20, x is 10. To find the y-intercept, it's like we cover up x. 5y is 20. 20 divided by 5 is 4. All right, these next two are exceptions. If you think about 5y equal to -60 and you divide by 5, you get y is equal to -12. And here x is equal to -12. One of these is a horizontal line, the other is a vertical line. It turns out y equals -12 is a horizontal line down here. You can see that it crosses the y-axis there at -12. Does it ever cross the x-intercept? Or does it ever cross the x-axis, I should say? No, there's none. If I sketched out this one, my graph is over here. It's a vertical line. It crosses the x-axis here at negative 12, and there is no y-intercept. Visually, the x-intercept is right here, where it crosses the x-axis at 4. The y-intercept is right here at 2. To find the y-intercept, we look at where the line crosses the y-axis at 3. To find the slope, we're going to look at any 2 points, let's say these two, and notice I'm going down 1 and right 4. Down 1 and right 4. That's a slope of negative 1/4. The x-intercept is where the line crosses the x-axis here at 4, and the y-intercept here at 2. Guess this problem got on there twice. Whoops. Let's look at the slope. For any 2 points, we are going up 2 and right 1. The slope is 2/1, or just 2. The slope for a vertical line is undefined. The slope for a horizontal line is 0. If you try to think of these in terms of rise over run, you would have some change in y divided by 0. You can't divide by 0. On the horizontal line, you would have 0 divided by some change in x. And that's always going to be 0 no matter what. To find the slope here, let's look at the change in y, which is plus 2. We'll put that on top. And the change in x, which is plus 1. We'll put that on the bottom. Our slope here is 2. At this point, I go down 3 and right 2. Negative 3/2 is my slope. Since this is a horizontal line, it has a slope of 0. To find the slope given 2 points, I use the slope formula, which is y2 minus y1 over x2 minus x1. Here, that works like this. 6 minus 2 over 2 minus 1. 6 minus 2 is 4. 2 minus 1 is 1. That simplifies to 4. We'll use that same formula, y2 minus y1 over x2 minus x1. This is negative 8 minus 4 all over 2 minus a negative 6. Negative 8 minus 4 is negative 12. Since there's 2 minuses, they become plus, and you get 8. If I simplify this a little bit, it's negative 3 divided by 2. That's my slope. This one I use the same formula, y2 minus y1 over x2 minus x1. This gives me 5 minus a negative 6 all over negative 11 minus a negative 11. 11 on top, 0 on bottom. This slope is undefined. You can't divide by 0. To graph this line, I'm going to go negative 1, negative 3, 0, negative 1, and 1, 1. Each of these values is turned into a coordinate. To graph this one, I'm going to start with my b value, which is my y-intercept, or my starting point, and I'm going to go down 2 and put a dot. Next up, negative 1/4 is my m value, and I think of that as rise over run. From this point, I go down 1 and right 4, and put a dot. Down 1, right 4, put a dot. And this is what my graph will look like. For this one, I have to solve for y. So I take 3x plus 4y is equal to 16. I subtract 3x from both sides. 4y is equal to negative 3x plus 16. And I divide all of the terms by 4. So y is equal to negative 3/4 x plus 4. I start with 4. That's my intercept. And then I use rise over run. And that's negative 3 over 4. So from this point, I go down 1, 2, 3, and I go to the right 1, 2, 3, 4, and I put a dot. If I wanted to, I could do another one. The pattern is you go down 3, right 4. Writing linear equations. My b value is always where I cross the y-axis. That's at 4. My m value is rise over run. I go down 4 and right 5. That's negative 4/5. That's my slope. I write this as negative 4/5 plus 4. For my vertical line, the slope is undefined. And the b value, or where it crosses the y-axis, is there's none. It'll never happen. For the equation, I write x is equal to 8, because any point on this line has an x value of 8. For this horizontal line, the slope is 0, and the b value is here at 4. My equation is y is equal to 4. A line has a slope of 2 and passes through these points. My goal is to find the b value. Then I can write my line. So if I think of y equals mx plus b, and I plug in for x, I plug in for y, and I plug in for m, I get 3 is equal to 2 times 1 plus b. b is my only variable left. 3 is equal to 2 plus b, or 1 is equal to b. So I have my slope, y is equal to 2x. I have my b value. There's my equation. Here I need to find both my slope and my intercept. So I can do y2 minus y1 over x2 minus x1 to find the slope. 2 minus 4 all over 0 minus a negative 2. This gives me negative 2 over 2. So m is negative 1. I'm going to plug that in, and I have y is equal to mx plus b. I'll pick this one, and I'm going to use 2 for y, negative 1 for my slope, 0 for my x, and I'm solving for b. Negative 1 times 0 goes away, so I have 2 is equal to b. I take these two things that I just solved for, and I build them into an equation. Y is equal to negative 1x plus 2. That's for the rookies, though. I could just write negative x plus 2. Given this table of values, what's the equation of the line? So first of all, notice here, I have the coordinate 0, 1. That means that my b value is 1, because that's the y-intercept. If I look at the change in this table, I can see that I am going plus 2 each time. Plus 2, plus 2, plus 2, plus 2. That's for the y's. The change in y is 2. What about the change in x? I'm going, not counting by 1s, I'm counting by 3s each time. So my slope here is going to be 2/3. If I want to put it all together, I have y is equal to 2/3 x plus 1. What is the slope of a line parallel to y is equal to negative 3/4 x minus 9? The slope for this one is negative 3/4. A parallel slope is going to be the exact same thing. So we're going to choose negative 3/4. For this line, our slope is negative 5. For perpendicular lines, I want to choose the opposite reciprocal. That means I take negative 5 and I flip it and I make it negative. So this becomes positive 1 over 5. You flip the fraction and you take the opposite. So which of these are parallel? My slope here is 1/4. My slope here is 0. My slope here is 4. My slope here is 1/4. These are the lines that are parallel because they have the same slope. My slope here is negative 1. My slope here is negative 1, negative 1, and 3. In fact, all three of these are parallel. My slope here is 3. My slope is 0. My slope for this one is undefined. And for this one, I have to solve it. So first I'm going to subtract x from both sides. I have negative 3y is equal to negative x plus 6. Then I'll divide everything by a negative 3. Y is equal to 1/3 x minus 2. So my slope is going to be 1/3. If I look at all of the different slopes here, this one and this one are perpendicular because 0 and undefined are perpendicular slopes. This is a vertical and a horizontal line. The next set, I have a slope of 1/2. I have a slope of negative 2. I have a slope of 0. And this one I have to solve. So let's take this. 2x minus y is equal to 1. I'm going to add y. And I have 2x is equal to 1 plus y. I'm going to subtract 1, and I have 2x minus 1 is equal to y. My slope then is 2. These two are perpendicular. You take 1/2, you flip it, and you make it negative. Write an equation that describes a line that passes through this point and is parallel to the line described by y is equal to 3x plus 2. Parallel means same slope. So if this slope is 3, then my m for the new line is going to be 3. And I can plug in to y equals mx plus b these values for x and y and m to find out my b. Negative 4 is equal to 3 times 2 plus b. Negative 4 is equal to 6 plus b. Negative 10 is equal to b. If I write the whole equation, I have to put these two things together. 3x minus 10. Another parallel problem. I know that my slope is going to be the same, so negative 2 over 5. This is going to be my x and my y. I'll plug it into y equals mx plus b, so I have negative 1 is equal to negative 2/5 times 2 plus b. If I rewrite this, I have negative 4/5 plus b. To solve for b, I'm going to add 4/5 to both sides. This gives me negative 1/5 is equal to b. If I plug in my slope, negative 2 over 5, in my b value, I have my equation for the line. Next up, perpendicular slopes. So if my slope here was 1, that's 1 over 1, and I'm going to flip it, which doesn't do anything, and add a negative. So my new slope is negative 1. This is my point. Let's plug it in. Consider the first one as x, the second one as y. We're plugging into y equals mx plus b. So I have negative 1 is equal to negative 1, my slope, times 4 plus b. Negative 1 is equal to negative 4 plus b. If I add 4 to both sides, I have 3 is equal to b. There's my intercept, there's my slope. I put it together, negative x plus 3. My original slope here is negative 1 over 8. I want the opposite reciprocal, so I flip it to 8 over 1, and that's my new slope. If I plug in negative 5 for y, 8 for my m, and 1 for my x, I'm getting the x and the y from here, I can solve for b. Negative 5 is equal to 8 plus b. If I subtract 8 from both sides, I get negative 13 is equal to b. If I put everything together, 8x minus 13.